All right, ladies and gentlemen, just an old-fashioned lecture here. We just did oxidation of alcohols using chromium-6. We're skipping periodic acid and NAD+ for now. We may come back for periodic acid. I want to see where we stand after, during Wednesday. I'm not giving you new stuff on Monday. So during this Wednesday, if I don't get to periodic acid, we're going to skip it. We're probably going to skip NAD+, although it's very important for biochemistry. It'll come up again in Orgo 2. But right now, we're just going to do a quick lecture on thiols. Monday is our final lecture. It's review day all day. Monday, next week. What is a thiol? I know what an alcohol is. Alcohol is ROH. ROH, and you better not have a carbonyl attached to the O, right? That'd be a carboxylic acid. This is normal R, like methyl. Thiol is what? R blank H. SH. Phi precursor always means sulfur is taking the place of oxygen. See if you can apply that information right now. Draw a thioether. Unrelated, but related. It's got phi. So, there's an ethyl attached to a sulfur attached to another ethyl. There you go. If that was oxygen, it's a normal ether. That's a thioether. Sulfur took the place of oxygen. Thioester, you ever heard of that? I think some of you have. Acetyl-CoA is a thioester that makes every lipid out there. Wow. All the carbons in your lipids come from acetyl-CoA. That's one of the hundreds of uses of acetyl-CoA. Hundreds. Anyway, we're looking ahead at that. What do you need to know about thiols? Well, you need to know how to name them. 1, 2, 3, 4. So you can call it 3-methyl-butane thiol or isopentyl thiol. You choose that way, it's 2 words. Or isopentyl mercaptan. What the? Mercaptan? I think there's an element hidden in there. Mercaptan, yeah. Mercury. Now, we're talking about the highest oxidation state of mercury here. Thiols. Oh, that's not the highest oxidation state of mercury. What are you talking about? +2. What happens is the mercury gets captured. Mercury just got captured. Does that tell you the name? Mercaptan? Mercury capture agent? A double portmanteau. What's that mean? Mercury? Oh. It's not just about chemistry, everybody. Mercury capture. I'm not sure the an is for this, but I like it. Agent. Mercaptan. I don't think it's an agent after all. So I got its name from what it does. Yes, sir. Oh. Over here?
Right, with the balance reaction.
Oh, yeah. Thank you. We're balanced now. In fact, the drug that treats you for mercury poisoning has thiol in it, okay? And it makes a chelate, which precipitates the mercury. You pass it, and you no longer get poisoned. So that mercaptan is just another way of saying thiol, right? Good enough? Have you heard about a certain animal, an odoriferous animal that emanates mercaptans from its nether region? I don't want to say what the region is. Skunk! That's one of the chemicals there. You want to see the other main chemical that makes a skunk smell like a skunk? Here it is. E2-butene thiol. Right? E2-butene thiol. Those two chemicals are the stink chemicals from a skunk. And you guys know how to get rid of the stink? I always get that answer. You said tomato juice, right? Yeah. Okay, so here's the scenario. Husband, wife, dog. Husband gets the dog from the yard. Dog stinks like a skunk. Husband gets the tomato juice because Honey's his friend. He phoned him up and he said, "What do I do, Honey?" He said, "Wash that dog with tomato juice." And the guy's washing the dog with tomato juice. He's saying, "It's working. I don't smell the skunk anymore." Guy's wife comes in and says, "Oh my God, get out of here. This place stinks." So what's happened there? The problem wasn't solved. The guy washing the dog, his nasal receptors got saturated with the tomato because he was working with it, right? The tomato smell. Okay? So it's just masking the skunk smell. The wife's getting the total skunk package because that's the first thing that hits you. It fits right in those receptors. So that's what they call the old wives' tale right there, the tomato juice, okay? It's not the answer. Maybe the answer lies in this fact. Oh, and the reason it's hard to get rid of the skunk stink, based on chemistry. What's the electronegativity of O and S? They're not the same number, are they? What's O? 3.5, second most electronegative element on the periodic table. What's C? This is the same as that, sorry, what's S? Same as asking what's I? CSI, what are they all? What's the number, please? Electronegativity, please. 2.5. So OH is polar, right? Extremely polar. SH, not polar. So you can't wash it away. Oh, there's the problem, honey. Tomato juice or water or whatever, it's not just washing away at all. It loves your skin. Those stinks, they get into your skin and they're non-polar. They stay in there with the lipid. It is now part of you. Okay? So washing's not an answer. Maybe acid-base is an answer. Maybe. And it could be an answer. Because this SH, not water soluble. For the reasons we just discussed, it's not polar. There's not a single polar bond in there. But my lab people will tell you that if you react it with KOH, you're going to get HOH, that's acid base, plus, cross off the old K, plus S minus. What am I trying to say there? What have I just said? Why did I put an AQ there? If it's aqueous, it means it dissolves in water, right? Well, my lab students know if you want to make something that more soluble, make it into an ion. Acid-base chemistry is a way you can do it as long as there's an acid around. Somebody take a wild guess to pKa here. Your wild guess should start with 17. Why did I say such a thing? It's not the right answer, but you should be starting there. 17 for its brother, the alcohol. What's the trend on the periodic table going down? You forgot? We're comparing, say, water to the next one down. I don't know. Let's not do that one. Let's do, which one are we supposed to know two of? Well, HF is not a strong acid and HCl is. What's the trend? pKa goes up, but acidity that way. Yeah. HI is stronger than HBr, is stronger than HCl, which are all much stronger than HF. The trend is more acidic that way because the ions get bigger. They're more stable. So pKa is 10. Why am I highlighting it? It's new. What's it called? Thiol. Please go to your pKa table, page 122 or something close to that. Add thiols where you added phenols. What? Maybe you didn't add phenols. This is an aside, so it doesn't belong there. Aside. Phenol, pKa 10. Why? Why not 17? Must be this anion's more stable than the anion of a normal alcohol. Tell me why. More stable than normal RO minus. Stable than normal RO minus. And the answer is here. You ready? Watch. What's going on? I'm not even going to draw the other resonance form. I'm just going to say etc. Resonance, right? Resonance. How many 10s you got now? How many 10s should be on your pKa table by this evening? There's one there already. It's called an ammonium ion. We're up to 3. By the end of Chem 242, you're up to about 10. Oh, 10? Popular number. 10 will be about the number of acids with that number. So you've solved the problem. You took the skunk scent and you made it dissolve in water by washing yourself with potassium hydroxide solution. Sadly, your skin is also burning. Hydroxide does saponification of lipids. It's another reaction that breaks lipids down. You don't want that. You need your lipids. Trust me, you need your lipids. Breaks proteins down too. It's not good at all. That chemical is too nasty for the purpose of de-stinking. Yes, 100% success getting rid of the smell, but you are now scarred permanently for the rest of your life. I don't think your wife's happy with you. Okay? The tomato juice was a much better answer. Sad story. You want the end of the story? Because the story's got to end sometime. Okay. Here we go. It's a good story, though. No, that's not the answer. Sorry, I apologize. Here's the whole sequence of this is oxidation, by the way. And you don't have to know the chemicals, yay. You just need to know that it's something sulfur can do. Sulfur's got a lot of oxidation states. There's only 2 more to go. And you'll see the one I almost gave by mistake earlier. I hope you see that these things are getting a little more polar. Why are you all moving? Please don't move on me. And the last one's one I think we're supposed to be familiar with already. Oh. These are both water soluble. Yeah. And you are responsible for the names of all these functional groups, starting from the far left, which we're supposed to know already. Wow. It's almost time to finish these notes. I wanted it smaller. There. What's the one on the far left called? A. You want the topic of the chapter? Thiol, right there, thiol. Now, I just want thiol. I just want to remind you, you know a different version of this one over here. I made you draw something like this on your test. What's the name of it? What's that stand for? Toluene sulfonic acid. This is a sulfonic acid. Sulfonic acids. This one. HOTS is a toluene. TS stands for toluene sulfonic. There you go. You guys know your alphabet, right? Give me the vowels alphabetically, please. It's going to help you a lot. A, E, I, O. You got the O right there. What's the next one backwards from O? I. Sulfinic acid. What's the next one backwards from I? E. Sulfanic acid. And you don't need sulfanic acid because it doesn't exist. Start from the end. Don't use the letter A. I know somebody's going to call this, and this would be funny if they did, a sulfinic acid with a Y. That's the last vowel. He told us to use the last vowel. I think that's hilarious. There's no sulfinic acid. So we have a lot of functional groups here. Only 2 of them are really new. You saw sulfonic acid before. You didn't know it was a thing. You saw thiol just now. And these 2 are brand new. And so, yeah, do you want to know the recipes published by the American Chemical Society for how to get your dog not stinking anymore? The oxidizing agent they use is a common one. H2O2 is your oxidizing agent. This is the de-skunkifying recipe. I can't say recipe. I can't tell you how much of each to use. I'd have to look it up. But the ingredients are H2O2, NaHCO3. A little base just makes this reaction work better. And a few drops of soap. And that's more for dissolving things than anything else. Just a couple drops of soap. That's it. 3 drops soap. The soap's not doing the job. It's just helping these chemicals dissolve. And there you go. And that's a good end of a lecture. Unless you want to talk about curling hair now. You don't want to talk about curling hair? Come on, it's fun. Okay, we won't talk about curling hair.